Welcome to your mid-semester oral exam for ENGN 2218. Thank you for showing me your student card so I could check your identity. Much appreciated. Beautiful. So what we're going to do today is you're going to be asked one of the 12 questions that I gave to you previously so you could prepare for this exam. And what we're going to do is we're going to throw a dice, and that will decide which of the problems that you answer. You all do have the option, if you really don't like that question, we can throw the dice again, but always remember that there's a risk because you might get a question that's even harder. So that it's your choice. All right, do you have any questions before we get started?
No questions.
All right. So what I'm going to do now, I'm going to throw my shake my dice, and you're going to tell me when to stop.
Stop.
Question 4. Okay, so I'm going to put question 4 up on your screen. Can you see question 4?
I can see question 4.
Lovely. So let's get started. So Jean, can you firstly describe the circuit? What is it called? And discuss the components you see as well as voltage sources. Over to you.
This is a Schmitt trigger. It's a type of comparator circuit, and this one consists of an op amp, 3 resistors, and 2 voltage sources. We have one voltage source, VCC, powering the op amp. We have our V in, which is providing a signal to the negative input of the op amp. One of our resistors is a feedback resistor, providing feedback from the output to the positive input of the Schmitt trigger, and our other 2 resistors are in parallel, grounding the positive input and creating a voltage differential.
Beautiful. All right, that covered the first question well. Thank you. Now, compared to other comparators that we've studied, what is special about the Schmitt trigger?
In terms of its behavior, unlike most comparators that generally have a single switch threshold, above that threshold the output's high and below it the output's low. The comparator has an upper trigger and a lower trigger threshold. When the voltage goes up above the upper trigger, the output goes high, and then when the voltage drops below the lower trigger, the output goes low again. In terms of its construction, it has positive feedback, whereas a regular comparator circuit has no feedback.
And what determines the upper and lower threshold voltages?
That's the value of that feedback resistor and those 2 grounding resistors.
Yeah. So you were talking about we've got this upper and this lower threshold voltage. Taking into account, how do we calculate the value of hysteresis?
Well, once you found that upper and lower voltage, you would take the lower voltage away from the upper voltage, and that would give you the width of the hysteresis loop.
All right, well done. We're on our last question already. We're rocking it.
Oh,
so,
wow.
Firstly, part A of the last question, why would we increase the value of hysteresis if we were designing a circuit? What would be a reason?
If you had a signal that was prone to large spikes, upwards or downwards, you would need a that you didn't want to be registered in the output. You need to make sure you have a larger hysteresis loop to make sure that those spikes don't trigger the output.
Right. And what would be a reason we would use to decrease the value of hysteresis in a design?
Well, I suppose it would be the opposite. If you had a signal that had a lot of small variation that you did need to capture in the output, you want to have a very small hysteresis loop so that you can capture those small variations in the output.
Yep. Much more. You want it to be more sensitive.
Exactly. That's
fantastic. Well, we're done, Jane. That was great. You have got awesome. 10 out of 10.
Amazing.
Full marks. And thank you for being the subject of our demonstration oral exam.
Lovely to be here.
Stopping recording.